What's going on, engineers? If you've been a long-time subscriber of this channel and you've been upset that there hasn't been any game development, then guess what? Today's your lucky day. In this video, we're going to be using Unity3D, which is a really popular game engine. And in particular, what we're doing in this video is we're going to create some components to interact with GameObjects. And if you don't know what components or GameObjects are, that's okay, because I'll be describing that as well. If you don't have any prior experience with Unity3D, that's perfectly okay. Keep on watching because you don't need any prior knowledge to benefit from this video. So let's go ahead and jump in and create some stuff. What you're seeing on the screen here is more or less what the Unity editor will look like by default when you create a new project. Now I'm not going to go into depth on how to install or create a new project because it's mostly self-explanatory. I'll put a link in the description below where you can go and download Unity. It's free, just register for a personal account, get Unity Hub, and then you can just install the latest version. Once you do that, you can click New Project, 3D Project, give it a name, and then it'll open up into what you see here. What we're looking at right now is called Scene View, which is nothing more than just a three-dimensional space to where game objects live. And there's a couple things up here you can use, like you can take the hand and then you can pan around to move the scene around. So currently there's nothing in the scene other than a camera and a light, but what we need to do is we're going to add a cube, which is what we're going to interact with. So to do that, we can right-click on Sample Scene, go to Game Object, 3D Object, and then click Cube, and this will create a cube here in the middle. Now we'll want to make this cube a little bigger and then rotate it a little bit so it looks 3D. So we can use our scale, move, and rotate. We'll grab here in the middle. We'll bring it out to us here a little bit more, a little bigger. Then we'll grab these little rotate wheels to rotate it so it looks like a 3D cube. Now we can use the tool to change the position, rotation, and scale of the cube, but the other thing we can do is look over here to the right at this thing we call the inspector, and then specifically under the subcategory called transform. Now under transform you have the position, rotation, and scale of this cube, and you have it in all three dimensions. Remember, it's a 3D project, so everything has an X, Y, and Z coordinate. So here we have the X, Y, Z for position, X, Y, Z for rotation, X, Y, Z for scale. And as we adjust this, we can see that the cube will move. If you wanted to adjust, say, the X rotation of the cube, you could click and hold on X, and then drag your mouse left and right. And you can see that it changes it. Now the inspector is nice if you want to set a default position, rotation, and scale of the game object, or this cube that we're looking at, but if you need to do something to it while the game is running, you have to use this thing called a component. Now components are nothing more than C# scripts that you can attach to game objects. Adding a new component is easy. Simply click the game object you want to add the component for, in this case cube, go to your inspector, scroll all the way to the bottom, and click this button called Add Component. So here's where you can search for a number of predefined components that come packaged with Unity3D, except in this case we want to create our own. And what we're trying to do to this cube is we want to just make this cube rotate infinitely. So we can call our component Infinite Rotate. And as we do this, we can see that it says New Script, and that's because Unity says, well, I don't have a script that looks like this, so go ahead and create a new script. As soon as I hit Enter, and then click Create and Add, it will create that script. You'll notice now at the bottom of the inspector it says Infinite Rotate Script, and now you know it's attached. Now to actually create the code for this component, we'll go to our project tab here and we'll see Infinite Rotate. Once we double click this, it'll open up Visual Studio. Once Visual Studio is open, we can open InfiniteRotate.cs on the right side here. Now once a component is added to a game object, certain lifecycle callbacks will begin to execute at certain points in time. And right here, this particular template has two of them shown. It has Start and Update. The start callback, like it says, start is called before the first frame update. So basically once as soon as it starts. And then update is going to be called once per frame, and depending on your frame rate will depend on how quickly that updates. So if the frame rate is 60 frames per second, then there'll be 60 update calls every second. We won't actually be using the start in this video, so we'll just go ahead and delete that. Now each game object has a transform property, and because this component is attached directly to our cube game object, we can access that transform by simply typing transform. And because we want to rotate our cube, the method we want to call is .rotate. The rotate method takes three arguments, a float x, float y, and float z. And keep in mind, this is not rotating the object to a given point, it's rotating the object by a given amount. So for instance, we're going to rotate it by, say, +2 for the x. We'll do like -0.3 for the y, and then we'll do 0.1 for the z. So remember, update gets called number of frames per second every second. So if it's 60, this is going to rotate it 60 times per second by the amount that I set. And now we're ready to test this. So we simply save, we click back over to Unity, click back over to our scene, and then we click play, and we see now that our cube is rotating quite nicely. At this point I can click on the cube and then I'll see kind of the little indicators there, but then I'll also see on the right hand side how all the values under the transform are constantly changing, and that's because that component is constantly updating them. This also helps us visualize the 3 dimensions that are being rotated. Now if we want it to stop executing, we'll just click the play button and that'll just stop everything, and it'll revert it back to what it was when we started playing. A cool feature about Unity is you can play it, and then while it's playing you can interact with it, like I'll make it much larger here. And then once I stop it, it just reverts all the changes. And this is really useful because it lets you experiment while it's running without having to worry about what you need to set back, because it'll set it back for you. Now what's really nifty about components is you can attach them to multiple game objects. So for instance, we have one cube here, but if we take this cube and we Control C and then Control V to paste it, now we have a second cube. We can also create a third cube. And then when we run this, you can see that we now actually have 3 cubes being rotated all at the same time, and it was no additional effort. Remember, we're not referencing cube 1, cube 2, cube 3. We simply created 3 cubes. Remember, all of them are GameObjects. And then we attach that component to each one of those cubes. That way it rotates it infinitely. The takeaway here is that components are highly reusable. So that was the first way of interacting with the cube, is by creating a component and attaching that component to the cube. So the second way we're going to do it is we're going to create a component, and then we're going to reference the cube in the component. Oh, and we're also going to make it animate back and forth across the screen. So we'll start by going to the inspector. We're going to click the little gear here. We're going to click remove component. We're no longer going to attach the infinite rotate component to this cube. So now there's nothing attached to the cube. What we want to do now is create an empty game object, which is going to be the object that we're going to use to attach our component to. So we'll go to sample scene. We'll go to game object and then create empty. And we can name this, we'll call it like game controller. Now the reason this is necessary is because you have to attach the component to something. So in this case we're going to create a new component and we're going to call it cube controller. Click new script, create and add. And just like before, it shows up in the inspector here, and then now to open this code we go to project and we double click our cube controller, and it should open up in Visual Studio. And it does, so here it is. And again, we don't need to start, so we'll just get rid of that now. Now because cube controller is not attached to the cube, we have no way to actually interact with it, and this is why we need to create an actual reference to that cube in this file. So to do that, we're going to create a public property, which is of type GameObject, and we're going to call it cube. Now when we click back into Unity, we're going to see something interesting happens. When we click on our game controller, we can see on the right hand side there's this thing called cube, and it says none of type GameObject. Now this is one real powerful feature of Unity. If we want to set that to a reference of cube, we come over here to under our scene, we grab cube, and we drag it over into that box. And when we let go, you can see that it's now set to cube. So now we'll go back to our code, and then the update method, we're going to use the exact same code that was in the previous file, except instead of transform, we're going to do cube.transform. And we have to do that because cube transform references the actual transform of the cube, whereas just transform references the transform of the cube controller, which of course we don't want to move that because you don't even see that. It's not even a thing that exists in the space. Now once we save this and go back to Unity and we click the run button, we can see that it functions exactly like it did before. We're just doing it a slightly different way. So we'll stop this real quick, and what we're looking at now is we want to move it on its z-axis. We can see that if we move it left and right on its z-axis, when it's all the way to the left, it's about at -15, and then when it's all the way to the right, it's going to be at about 15. So we want to move it from a range of -15 to 15. So let's go into our code and make that happen. We'll start by creating an enumeration called direction, which can have the values of either left or right, because the cube will either be moving left or right. We'll then say a default direction. We'll do direction dir equals direction.right, just as a default. So it'll start moving to the right first. When it gets to the end, it'll come all the way back, and it'll start going right again. So because we need to track the exact position to know when to turn the cube around, instead of actually moving it by a given value, we're actually going to move it to specific points. And to do that, we have to create what's called a vector 3. So we're going to do vector 3 position. And then all of vector 3 is 3 points, x, y, and z, that you can apply to different transform properties. So we have our vector 3 position equals new vector 3. And then in here, it's going to take again that x, y, and z. And the x and the y is easy because we're not actually modifying that. We're going to be moving this on its z-axis. So for these first two arguments, we can simply do cube.transform.position.x. And then for the second one, we can do .y. And that just says set the x and the y position to what the current x and y position is. It's the z value that we're going to have to calculate. So right now we're just going to put z, which will be a placeholder for our future variable. And then we'll come down here, and to actually modify the position of the cube, we'll simply do cube.transform.position, and then we'll just set it to the vector 3 that we just created. So we'll start by creating the z variable, and we're going to set it by default to cube.transform.position.z. And then here we'll actually adjust the z variable. So we'll do z plus equals, and then we'll have to check what dir is. So we'll do if dir is direction.right, then we will adjust it by 0.8f because it's going to the right. If it's left, then we'll adjust it by negative 0.8f. Now if we were to run this program right now, all it's going to happen is the cube is just going to start moving to the right, and it's just going to go on to infinity. So what we got to do now is we have to detect when the cube is at 15, and then reverse it, have it go backwards. And then likewise, we have to detect when it's at negative 15, and then reverse it again. So to do this, we're going to use a thing called mathf.clamp, and then we're going to provide it 3 arguments. The first argument is the current value. The second argument is going to be the minimum, so we'll do negative 15f, and then the next value is the maximum, so we'll do 15f. And the way mathf.clamp works is it either returns the given value, or it returns the minimum if the value is below the minimum, or it returns the maximum if the value is above the maximum. So if the z position is 100, it'll return 15. If the z position is negative 50, it'll return negative 15. And the reason we do this is because now it's very easy to just check if z is negative 15 or 15. So we can do if z equals negative 15f, in which case we will set the direction to direction.right. And then likewise, if it's going to be positive 15f, then we'll simply set it to left. And at this point our code should be pretty much done, so we'll go ahead and save it. We'll go back to Unity, or run our program and see what happens. You can see now our cube is doing exactly what we want. It's going back and forth, but it's also rotating. And just like before, we can see in our inspector where it's modifying all the values here. You can see the rotation's constantly changing because we're changing all the rotational values in the code, but only the z value is changing here. You can see that it goes all the way to negative 15, and then it goes all the way to positive 15, just like we wanted it. And that's it, we're done. That wasn't so hard, right? If you want to check out this exact project, there's a link in the description below, which you can get to it on GitHub. Also, if you have any questions or comments, or if you'd like to see more game design in the future, make sure you let me know in the comments down below. Other than that, thanks for watching. I hope to see you on the next video. Take care.